Hey, it's Mr. Luneski with Unit 9, Section 4. We are going to be looking at different angles that occur inside or outside of the triangle. So in Section 2, we talked about central angles, and so just as a reminder, the central angle formula is that the arc is equal to the angle. In section 3, we talked about if the vertex is on the circle, it was an inscribed angle, and the formula for that was arc equals 2 times the angle. So now we're going to look at, well, what happens if the vertex is inside the circle but not on the center? So one thing I want to point out in these three examples here, the angles that are provided are not on the circle. We can't, or I'm sorry, is not on the center of the circle. We can't really assume that this is the center, or we can't assume that that's the center. It usually has to be marked, or we have to be told that it's the center. So the formula that we're going to use for that is arc plus arc is equal to 2 times the angle. So for this particular example here, I could say arc DC and arc AB are going to equal 2 times the measure of angle 1. So essentially we're looking at the vertical angles here. If you remember, vertical angles are when there's an X and it's the two angles that are sort of across from each other. I could also say that arc AD, which is up here, plus arc BC is equal to 2 times angle 2, because that's sort of the ice cream cone that's catching arc BC. So I wanted to show you two examples of what this looks like. So again, here we have the vertex of the angle happening inside the circle. So when it's inside the circle, we're going to add, inside add. And so it's going to be arc of 40 degrees and arc of 80 degrees. Those are sort of the two arcs that these vertical angles capture. So the setup's going to look like this. 40 plus 80 equals 2 times the angle. And the angle is x. So then from here we just solve for x. So we get 120 equals 2x, divide both sides by 2, we get x equals 60. Down here, if you notice, the angle that's given to us is this 128, but the arcs are not with that angle. So we need to figure out what this angle or this angle is. So to do that, we still have a linear pair. So we can solve by kind of doing our linear pair bit, which if you remember, that's 180 minus the angle. So we can say that this angle here is 52 degrees. Now we can do arc plus arc is equal to 2 times the angle. So we get something like this. So arc is x plus the other arc is 34 is equal to 2 times the angle that's happening inside, it's 52. And then again, just solve for x. So multiply by 2 here, subtract 34 from both sides, we get x is equal to 70. Another place that these angles can occur is outside the circle. So when it's inside, we add. When it's outside, we subtract. So essentially, we're going to do arc minus arc is equal to 2 times the angle. Whenever you're subtracting, you always want to make sure that you're doing the big arc minus the small arc. Otherwise, you're going to get negative values, and negative values won't make sense here. So if you ever catch yourself getting sort of a negative value, you would know something went wrong. So now when I say arc minus arc, if this was our example here, we would say the arcs that are sort of caught in between the angles. So it would be arc BC, and then it would be arc AC. So this is the bigger arc, so it would be BC minus AC equals 2 times the angle. So here, when we're looking at this figure, we have the angle, and then it's catching this arc, and then the smaller arc that it catches is here. So when we set that up, again, it's just arc minus arc equals 2 times the angle. So we have 100 minus 30 equals 2 times x. Again, just simplify and solve for x. So x equals 35 in this example here. The outside can happen in a couple of different ways. So this way that we just looked at was if I had a tangent line and a secant line. So remember, tangent just touches the circle at 1 point, secant goes through the circle at 2 points. Well, what if I had 2 tangent lines? So again, here my angle is angle 2, and then the arc, notice that this is sort of catching the entire circle. So we have arc PQR as sort of our big outside arc, and then we have arc PR, which is our inside. So we're still going to do arc minus arc equals 2 times angle, so it looks something like this. Where these problems get a bit tricky is on this example. So we're given angle x, but we're only given this arc here is 96 degrees. So then the issue is that we don't know what this arc here is. But if you remember that a circle is 360 degrees, we can do 360 minus 96, and then we figure out that this big outside arc is 264. And now we can do the problem. So it's 264 minus 96. That equals 2 times the angle. So again, simplify, solve for x. We get that x is equal to 84 degrees. Another way that we can get an outside angle is if we have two secant lines. So this one, we still are looking at the arcs that are inside sort of the secant lines. So it's this minus this equals 2 times the angle. And that's really just the base formula for it. Arc minus arc equals 2 times angle. So here, if we wanted to solve for angle A, if it helps to put an x there, you can put an x there, that's fine, or you just leave it as angle A. So this will do 120 minus 40 is equal to 2 times angle A. Again, simplify and solve. So we end up getting that angle A, or the measure of angle A, is 40 degrees. When you're doing these problems, now we sort of have 4 different places that the angle can occur. Anytime you get to a problem, you should sort of ask yourself, where is the vertex of the angle? If the vertex is in the center of the circle, then you're going to use the formula arc equals the angle. If your vertex is on the circle, that's an inscribed angle, so that's going to be arc equals 2 times the angle. If it happens inside the circle but not at the center, that's when you do arc plus arc equals 2 times the angle. And then when it happens outside, it's going to be arc minus arc equals 2 times the angle. What I want to point out to you is when it's on, inside, or outside, you're always going to do 2 times the angle. So really it's just a matter of remembering that when it's inside we add, when it's outside we subtract. And that's kind of it for it. So take a quick moment. There are 2 example problems here. Try those out for yourself. You can pause the video if you'd like. I'm going to reveal the answers here when you've tried them. Alright, let's take a peek. Did you get these answers? Hopefully you did. These were both outside the circles, so we're going to subtract. So arc minus arc equals 2 times the angle. Okay, so that is it for section 4. Thank you for watching. I know it, and now you know it.